Welcome to 3.17's Math Moment. Today was the last lesson in Unit 3, and what students did was they took everything that they learned in Unit 3 and did just a lot of mixed practice. So they saw decimals today, they saw fractions today, they were adding, multiplying, subtracting, doing all sorts of different things. So we're just going to look at two examples. If these examples don't help you with the question that your student might have tonight on their homework, please refer back to some other lessons and other videos in the unit to maybe help you, because today is just truly a practice day. So the first example we looked at, it says Jennifer practices cheerleading for 5 hours a week. Jessica spends 8/9 as much time practicing as Jennifer. How much time does Jessica spend? So I know how much Jennifer practiced. She practiced 5 hours. What I don't know is exactly how much Jessica spent practicing. I know that she spent 8/9 as much as Jennifer, so I've got to do some math to figure out exactly what that is. Well, 8/9 as much time makes me think multiplication because of kind of that connection between of and as much. So I've got 5 hours that Jennifer spent, and if I want to make that look like a fraction, I'm going to put it over 1, and then it's 8/9 as much. So 8/9 is going to be times 8/9. So I'm going to take top times top, 50 times 8, and bottom times bottom, 1 times 9. This is obviously an improper fraction. The top is way too big, so I'm going to divide 40 divided by 9. If I count by 9s, I can think that 9 goes in 4 times to get me 36. When I subtract, I can't do 0 minus 6, so I'm going to borrow from the 4. 10 minus 6 is 4. 3 minus 3 is 0. So I have 4 left over to make my new numerator. So this fraction is actually equivalent to the mixed number 4 and 4/9. So let's think about this answer. How much time does Jessica spend? She spent 4 and 4/9 of an hour. Does that make sense? It said that Jessica spent 8/9 as much time as Jennifer. Jennifer spent 5. Well, 8/9 is very, very close to 9/9, which would be 1 whole, which means that they would have practiced the exact same amount, 5 hours. So is 4 and 4/9 pretty close to 5 as well? Yes. So my answer makes sense and it is reasonable. All right, and I answered everything that they wanted me to do. How much time does Jessica spend? 4 and 4/9 hours. In example 2, it says, an apple juice factory produced 495 and 3/10 gallons of apple juice in 3 and 5/10 days, or 3.5 days. How much apple juice, on average, did the factory produce each day? So, this makes me think that I'm going to be taking those gallons and the number of days, and I'm going to be kind of splitting it. Okay, on this day I did this much, this day I did this much, this day I did this much. All right, and how many did they produce each day? I'm taking that big number, 495 and 3/10, and I'm splitting it into how many days I worked, which was 3 and 5/10. So this to me is a division problem. So I am going to move my division right over here so I have room. And I've got 495 and 3/10 divided by 3 and 5/10. Now, students learn that when there's a decimal on the outside of a division problem, you've got to move it so it's at the very, very end. But whatever you do to that outside number, you also have to do to the inside number. So I'm going to move it 1 spot. That makes the decimal point go straight up here in my answer, and that's where it will stay no matter what numbers I place. So now I just solve it like a regular division problem. 35 goes into 4. It cannot. So I place an X or a 0. 35 goes into 49. I'm using mental math to decide that that probably just goes in 1 time. 9 minus 5 is 4, and 4 minus 3 is 1. And then I bring down my 5. Now, I don't know how many times 35 can go into 145. I don't know my 35s by heart. So I'm going to just guess and check and do times 4 to see if I can get close. All right, so 5 times 4 gives me 20. 4 times 3 gives me 12, plus 2 would be 14. All right, and that got me pretty close to 145. It's exactly 140. So I'm going to place the 4 on top and my 140 down below. 5 minus 0 is 5, and then I have zeros left. I bring down my 3, And now I need to decide how many times can 35 go into 53. Well, probably only once, but once we subtract and make sure, 3 minus 5 I cannot do, so I borrow. 13 minus 5 is 8. 4 minus 3 is 1. 18 is still less than 35, so I feel good about that. All right, and now because I have a remainder, I need to keep going and add a 0 in order to do so. So how many times can 35 go into 180? Well, 35 times 4 was 140, so now I'm going to try maybe 35 times 5. 5 times 5 is 25. 5 times 3 is 15, plus 2, 17, gets me very close. 175. When I subtract, I'm going to be left with 5 again. So I add another 0. Let's not forget to put our 5 up there. All right, now I have 50 and I need to decide how many times does 35 go into 50. Well, I know it goes in about 1 time. I did a problem similar to this earlier. I'm left with 15. All right, and now I could keep going and see how far I want to continue my decimal. But most of the time, teachers allow students to stop dividing and bringing down zeros after they have 2 to 3 numbers behind the decimal, because then we can round and we can make a pretty good assumption about our answer. So here I have added 2 spots behind the decimals. I added 2 zeros to get there, and so I'm going to say that this is my best answer right now. So how much apple juice on average did the factory produce each day? 141 and 51 hundredths. Now, if I wanted to keep going, I could then round that 51 and make it a little bit nicer to work with, but this would work as well. So each day, this is about how much juice that they produced. If you have any other questions about Unit 3, Lesson 17, please see your math teacher.